if you're using Syslog or SNMP, you're gathering statistics on your devices, it's really important that you know when certain events have occurred. This is also true if there's any type of security breach. As you're looking at the log messages, what time did those security breaches occur? It would be really, really important to know that, especially if you're doing any type of forensic analysis on the network. Because you're eventually going to be in a court of law. You need that information. So how can we make sure that our devices have accurate time? Because we can configure all of our end stations, all of our routers, all of our switches, all of our servers with their system clock. However, those clocks are not going to stay the same all the time. You could have what is known as drifting with your time. And as a result, over a year, the clocks might be off by 2 minutes, 3 minutes, 4 minutes, who knows? What we can use instead is Network Time Protocol, NTP, which is a protocol using port number 123. I like that. NTP is time, 123, first three numbers of a clock, pretty easy to remember. But what NTP gives us the ability to do is have our devices synchronize their clocks with an authoritative time source. So we can have that authoritative time source either in our organization or preferably outside of our organization. And the time for that authoritative source is coming from a very accurate time source like an atomic clock or a GPS receiver. So for example, the U.S. Naval Observatory has their NTP server connected to that external atomic clock. And then you are accessing you are receiving time from that authentic time source. Your devices in your organization are getting their time from not necessarily the authentic time source, but maybe a router in your environment that's relaying that information to the end stations. So we have a hierarchical system here with NTP, and it's based on the concept of stratum. So we have these different stratum values, stratum 1 being the most authentic. So if we look at this device here, that's our U.S. Naval Observatory PC, device, server, whatever it happens to be, connected to the atomic clock, and that time is super accurate. Everybody trusts that time. And so they are synchronizing their devices or a specific device in their organization up to that server. And notice what the stratum level becomes on that device in the hierarchy. It's now a stratum level of 2. So let's say this is an edge router in our network. Just as an example, it is now a stratum level of 2. It received its time from this server. Well, what about the other servers and routers and switches and components in our organization? Well, we could either synchronize up to the stratum level of 1 and become a stratum level of 2, or we could synchronize up to that edge router in our organization, or that other server that is now the NTP trusted source in our organization. And what would we become? A stratum level of 3. So as you move one device further and further away as you do your hierarchical synchronization process, it becomes one more stratum level within the organization. So there's different modes we can use for NTP. We can be a server. And what does a server do? A server provides time to clients. Now it's important to realize that when we say server, we're not necessarily referring to that atomic clock that's at the U.S. Naval Observatory. What are we referring to? Well, if my edge router in my organization is receiving time from that authentic NTP device on the internet, well, it's a client of that device. But I could also have my device be a server to the clients in my organization. So the server is a general definition for a device that can provide accurate time to the clients using NTP. So the client is the device that's going to synchronize its time to the server. But don't forget, you could be a client to a server and then be a server to the devices behind you because of the hierarchy we're dealing with here. If we want to provide high availability and redundancy, we can even implement peers. What do we mean by peers here? Well, let's think about two edge routers in our organization. We have one edge router connected up to the internet, another edge router connected up to the internet, and they're both getting their time from the U.S. Naval Observatory authentic NTP server. Well, what happens if this device loses connectivity to the internet? Does it have the ability to receive its time? The answer to that is no. So what happens to its clients? Well, its clients are going to suffer because of an issue with time now. So instead, we could have these two edge routers peer together, so that way there, if they fail to contact their server for the authentic time, they can rely on their peer to give them the time they need to hand out to the clients behind them. So it's going to give us better availability of the NTP devices in our organization. We also have the ability to do a broadcast and multicast type of push model for NTP. So how is that different than NTP in general? Well, NTP is a client-initiated process. What that means is the client is going to reach out to the server and say, hey, I need time. And then the server provides it time. However, we could set it up also as a broadcast or multicast type of push model where we have the server pushing out time down to devices. Where would this work? This would work in our local area networks. So you could have your router, your default gateway, your multi-layer switch set up to use the broadcast push model or a multicast push model and just simply push time down to those end stations.